Hey guys, just wanted to do a few extra examples for 6-2 day 3 that might be on the online assignment, okay? Well, let me just show you how to use the calculator because I've been asking you to do all of these things by hand, finding exact values. So some problems you're gonna have to use a calculator for. If they don't ask you a special angle like 30, 60, 45, 90, 180, anything that's a multiple of those 30, 60 to 45s, these are just random angles that we don't have that special side length relationship that we can whip up in a right triangle. So these ones you have to use calculators for. So they can ask you it to find the cosine of an angle that's in degrees, but they can also ask you to find the tangent or the cosine or sine of an angle that's in radians. So the mode that you have your calculator in, the mode is going to matter. You got to watch that. So let me show you what you can do. So if you're working with a graphing calculator, then you're going to want to go to the mode right here. And when you hit, oh, mine turned off. When you hit mode, right here, it says it's in radians because radians has the black box behind it. But if it had the black box, if it had the black box behind degree, then your calculator would be in degree. So technically, if you're going to be asked to find the cosine of a 48-degree angle, you really want your calculator in degrees. Otherwise, you're not in the right unit. However, I can give you a trick so you don't have to worry about flipping back and forth because most of your calculators are probably already in radians because radians measure angles as real numbers, not degrees technically. So I would advise you leave it in radians because that's normally what we use it in. Get out of there. So when you want to find the cosine of 48 degrees, just do this. You can't ask it to find, let me get it, cosine is right here. So hit the cosine button, it pops up. You can't ask it cosine 48 because right now that's technically considered to be 48 radians. And I don't want it to be 48 radians. I want it to be 48 degrees. So if you go to your second angle button, just get the degree sign that we used to use, and now you've literally specified that you are finding the cosine of 48 degrees. So as long as you put the degree on the 48, you have told your calculator that this is 48 degrees, even though the mode is in radians, and then you don't have to keep switching it back and forth. So the cosine of 48 degrees, hit enter. Now it's going to get you an estimated ratio, right? So now the ratio is given to us as a decimal. It's 0.6691. I'm just going to round to 4 decimal places. 0.6691 is your answer, okay? All right. Otherwise, you'd have to keep going to mode and switching back between radians and degrees. And I think that would be annoying. So as long as you use the degree symbol, you can leave your calculator in radians. All right, let me get out of there. All right, so let's do the next one. What if they want the cosecant of 321 degrees? Well, guys, remember, there are no reciprocal trig buttons. There's no cosecant button. There's no secant button. There's no cotangent button. So you literally have to rewrite this as he's the reciprocal of sine. So that is 1 over the sine of 321 degrees. That's how you have to ask your calculator to find that. So you go to your calculator and you literally put 1 division sign and then go get the sine button. Mine is right here. And then it's going to be the sine of 321. We'll get my degree symbol because I am technically in radians right now. And then close it, and then that is technically how you find the cosecant of 321 degrees. Hit enter, and it gets you the ratio as a decimal, and I'm going to say it's negative 1.5890. Negative 1.5890, okay? Now, if you're not working on a graphing calculator, it's the same thing. Now, I only have a TI-36 at home, so for me, I have to go to mode. Oh, this is off. I have to go to mode, and again, I have to play with the degrees, radians, and that's a gradient. We don't use that. So it's always between degrees and radians. So I can just toggle back and forth. So like I said, if you want to leave it in radians, second, quit. Now my calculator literally says rad there, so I know it's in radians. So now again, if I want to find the cosine of 48 degrees, I got to get my cosine button, which is right there for me. Cosine, put in 48, and then again, this one also has, I have to go into math, I believe, on this one. And if I go to degrees, minutes, second, I can get that degree symbol. And then there it is, the cosine of 48 degrees, hit enter, and it's that 0.6691 again, okay? All right, I'm gonna use my graphing calculator. I'm gonna try and go faster on these ones. So what if they asked you the cotangent of 113 degrees? Well, there's no cotangent button, so really that's 1 over the tangent of 113 degrees. So on your calculator, I'm going to put 1 divided by, I'm going to go get my tangent button, which is right there, and then it's 113, get my degree symbol, which is under angle, and now I'm taking the cotangent of 113 degrees, hit enter, and it's negative 0.4245. And again, think about it. 113 degrees lands in quadrant 2. So the cotangent or tangent of an angle in quadrant 2 should be a negative ratio. So that makes sense, right? All students take calculus. All right, here we go. Look at this one. Now, the tangent of pi over 12. If there's no degree symbol, then you have to assume that that is a radian measurement. So just go on your calculator. We should already be in radians, and you can double check if you're unsure, but I am definitely in radians. So second quit. You're going to ask it to get the tangent of, now you can literally just put in pi over 12 because you're in radians. So go get your pi button, pi divided by 12, and that is the tangent of pi over 12 radians. Hit enter, and it gets you your ratio, which is 0.2679. Okay, well, if that ratio is positive, then this angle either landed in quadrant 1 or quadrant 3, because tangent ratios are positive for angles in quadrant 1 and quadrant 3. 180 divided by 12 is a pretty small number, so he must be in quadrant 1. Must be between 0 and 90. All right. What about the cosine of 3 pi's over 5? Well, again, there's no degree symbol, so I have to assume I'm in radians. So get your cosine button, which is right there for me, and then I'm going to type in 3, go get my pi button, divide it by 5, and that is the cosine of 3 pi over 5. Hit enter, and my ratio is negative 0.03, negative 0.3090. And that is your ratio. All right, last one, the secant of pi over 7. Well, again, there is no secant button, so we're going to rewrite this as 1 divided by, secant's the reciprocal of cosine, so 1 over the cosine of pi over 7 radians. So on your calculator, put 1 divided by, go get your cosine, and put in your pi divided by 7. Hit enter. So 1 divided by the cosine of pi over 7, the ratio is 1.1099. Okay, so that's how you can use your calculator. All right, let's do another one. All right, now it says, find the exact value of. Well, they want to know what is 5 times the cosine of 90 degrees minus 8 times the sine of 270 degrees. Well, I have to figure out what these ratios are. What is the ratio of the cosine of 90 degrees? Well, guys, where does 90 degrees land on your unit circle? 90 degrees lands right there at what ordered pair? Up 1 would be 0, 1. So the cosine at 90 degrees is the x-coordinate. What is the x-coordinate? 0. So that is 5 times 0, and then minus 8 times, what is the sine of 270 degrees? Well, where does 270 degrees land? Right there. And what ordered pair lives on your unit circle right there at 270 degrees? That's down 1, that's 0, negative 1. So the sine is the y-coordinate. So what is the y-coordinate? It's negative 1. So that's 8 times negative 1. So now, 5 times 0, 0. Subtract 8 times negative 1 is negative 8. So 0 minus negative 8 turns to plus, and the answer is 8. Okay? All right, look at this one. 2 times the sine of pi over 3 minus 3 times the tangent of pi over 6. Well, first we got to figure out what these ratios are. What is the sine of pi over 3? So 2 times, well, what is the sine of pi over 3? Well, where do pi over 3's land? they land right there in quadrant 1. So you are literally taking the sine of pi over 3 and it landed in quadrant 1. Well, what is the sine of pi over 3? That's a 60-degree angle, guys. So give yourself, whip up a right triangle, right? You got a 60, a 30. What are your special side lengths on a 30, 60, 90 right triangle? Well, remember, the smallest angle gets the smallest side, 1. The next biggest angle gets the next biggest side, root 3. And then the 90 gets the biggest side, which is 2. So if you can whip that up, you won't even need your unit circle. Otherwise, you would literally go look on your unit circle, go to the pi over 3, the 60 degrees, and the sine would be his y coordinate. But I don't need that. All right, so what's the sine of pi over 3? What's the sine of 60? Sine is O over H. Root 3 over 2 is root 3 over 2. So that's 2 times root 3 over 2. And it's obviously positive because it's in quadrant 1. All right, and then we're minusing 3 times. What is the tangent of pi over 6? Well, guys, that's the tangent of a 30-degree angle. Well, what's the tangent of a 30-degree angle? Tangent is supposed to be O over A. So O over A is 1 over root 3. Now, you could even leave it as 1 over root 3 if you wanted to.
Mommy, what's that black thing?
What, bud?
What's that black thing?
I'll be right there, hon. Hold on one second. So tangent pi over 6. Tangent 30 is 1 over root 3, which cleans up to...
You got it? See it?
Root 3 over 3. So that is root 3 over 3. Sorry, my son got me distracted there. All right, so now look here. So now let's clean it up. What happens to these 2's? They cancel. So you're left with root 3, subtract. What happens to these 3's? They cancel, and you're left with root 3. So what's root 3 minus root 3? 0 is the answer to this expression. Okay? All right. What if they asked for 3 times the cosecant of pi over 3 plus the cotangent of pi over 4? Well, let's get it. What's the cosecant of pi over 3? Well, guys, the cosecant of pi over 3 is the cosecant of 60. So we should be able to work right in our right triangle because that's a quadrant 1 angle and all ratios are positive for quadrant 1 angles. Give yourself another 60, 30. The more times you practice whipping this up, the easier it'll be to do. And now we can use it. So now what is the cosecant of a 60-degree angle? Pi over 3, right? Well, working off the 60. Cosecant is the reciprocal of sine. So sine used to be O over H. So the secant would be 2 over root 3. Okay, so now if I get that, that would be 3 times 2 over root 3, right? Well, that cleans up to, am I even on the screen? Yes. 2 root 3 over 3. So the cosecant of pi over 3 is 2 root 3 over 3. And then we're going to add that with what's the cotangent of pi over 4? Well, pi over 4 is 45 degrees, right? We should know that. So if you whip up a 45, 45, 90, 45, 45, 90. He has special side lengths 1, 1 to root 2. So now the cotangent is the reciprocal of tangent. So the tangent of a 45 would have been O over A, 1 over 1. But the cotangent is A over O. It's still 1 over 1. So it's 1. All right, so then what do we get? These 3's cancel, and you're left with 2 root 3 plus 1. Except you can't really add them together, so you're done. And that expression is your answer. Okay? All right, keep going. What about these ones? Then they start giving them to you as like f of x. What's the matter, bud? You're wearing your glasses? Good job. I'll be done in a minute. All right. Now they're going to give them to you as functions. So let's say they say, let f of theta equal sine theta, and let g of theta equal cosine theta. Thank you. Thanks, bud. If theta equals 60 degrees, find the exact value of all of these. And you can't use a calculator because you should be able to do these ones without a calculator, especially if theta is 60, because he's one of our special angles that lives inside of one of those right triangles. Remember, 30s, 60s, 45s, multiples of them, they are the good guys. All right, so let's say they asked you to find f of theta squared. Well, first of all, f of theta. They just said theta is 60 degrees. So f of theta is really f of 60 degrees. And then it's squared. Well, how do I find f of 60? I plug 60 into function f, which is sine theta. So really, f of 60 degrees is you finding the sine of a 60-degree angle, and then you square it. Well, what is the sine of a 60-degree angle? Well, again, either look at your unit circle, or if you can whip up a special right triangle real quick, the side lengths are 1 to root 3 to 2. So what's the sine of a 60? The sine of a 60 is O over H, root 3 over 2. So that's root 3 over 2, except now I have to square it. So square the top, 3, square the bottom, 4. The answer is 3/4. Okay, look at this one. What is G of 2 times theta? Well, they already told us that theta is 60 degrees. So that's really G of 2 times 60 degrees. So that's G of 2 times 60 degrees is 120 degrees. So G of 120 degrees means that you are plugging 120 degrees into the cosine function. So really that is the cosine of 120 degrees. So what's the cosine of 120 degrees? Well, what quadrant does 120 degrees land in? Right there. What is your reference angle, the angle that would fit inside of a right triangle right here? That would be 60 degrees. So what you're really doing is taking the cosine of a 60-degree angle that landed in quadrant 2. Well, what is the cosine of a 60? Let's work off this triangle. The cosine of a 60 is A over H. So that's 1 over 2. So it's 1/2. But what is the cosine ratio for an angle that landed in quadrant 2? All students take calculus. It says that only the sine function gets you a positive ratio for an angle in quadrant 2, which means the cosine ratio is negative. Because guess what? The x-coordinate would represent the cosine, and the x-coordinates are negative in quadrant 2. So the answer is -1/2. Okay. How about this one? What's 2 times f of theta going to be? Well, remember, they already told us that theta is 60. So this is 2 times f of 60 degrees. All right, well, f of 60 degrees means you're plugging 60 degrees into function f. Well, if you plug 60 degrees into function f, that means you're taking the sine of 60 degrees. So this is really 2 times the sine of 60 degrees. Well, what is the sine of 60 degrees? Go to your triangle. What's the sine? Sine is O over H. That's root 3 over 2, and that's an angle in quadrant 1, so the ratio is definitely positive. So it's root 3 over 2 times 2. My 2's cancel, and my answer is root 3. Okay? All right. I think I have just 2 more examples. All right. All right, pretty similar to the ones we just did. Still working with them as f of x and g of x. So f of x is going to equal sine x. So if you plug an x value in, you're taking the sine of that. And g of x equals cosine x. All right, find the exact value of. Again, exact usually means that you shouldn't be using a calculator. All right, what if they asked you to find f plus g of pi? Well, remember, f plus g means they want you to add f and g together. So really, if you think about it, f plus g of pi is really asking you to find f of pi plus g of pi. And then I kind of separate it into 2 separate problems. First, I got to plug pi into f, then I got to plug pi into g. So f of pi is literally you plugging pi into the f function, which means you'll be taking the sine of pi. And then I have to add it with g of pi, means you're plugging pi into the g of x function, so I'll be taking the cosine of pi. Okay, well, what do I get? What's the sine of pi? Well, where's pi radians going to land? Pi radians lands right there. What coordinate is that on your unit circle, right? That is the point -1, 0, because it's left 1. Well, sine is the y coordinate, so the sine at pi is 0. And then you're going to add that with the cosine of pi. Well, we're already at pi. The cosine of pi radians is the x-coordinate, which is -1. So what's 0 plus -1? -1. All right. All right, last one. What about f times g of 3 pi over 4? So really they're asking you to times these functions together or to times these values together. So I like to separate it. You're really finding f of 3 pi over 4 and you're timesing it with g of 3 pi over 4. So let's do this one first. F of 3 pi over 4 means you're plugging 3 pi over 4 into the sine function. So that's the sine of 3 pi over 4. And then you're going to times that with g of 3 pi over 4 means you're plugging 3 pi over 4 into g. So when you plug 3 pi over 4 into g, you're finding the cosine of 3 pi over 4. And now we've got to figure out what ratios these are. All right, well, sine of 3 pi over 4. Where do 3 pi's over 4 land? 3 pi's over 4, right? Well, let's get our anchors. This is pi over here, halfway around, and this is 2 pi. So in the world of pi's over 4, this is 4 pi's over 4, and this is 8 pi's over 4. So 3 pi's over 4 are going to land in the quadrant right before 4 pi's over 4. So 3 pi's over 4 are right there. So what is your reference angle in between 4 pi over 4 and 3 pi over 4 right here? Because that's actually the angle who's going to fit inside the right triangle. And it's going to be 1, oh, my camera isn't focusing. There you go. It's going to be 1 pi over 4. So what you're really doing for this is you are finding the sine of pi over 4, but it landed in quadrant 2. So what is the sine of a 45-degree angle? Because that's who pi over 4 is. Well, guys, get your special right triangle. Again, you could use your unit circle if you wanted to. Go to it, go to that angle and get me the y coordinate, but I prefer to do it this way because I don't know how often I'm going to have a unit circle on me. So a 45, 45, 90. What is his side lengths? 1 to 1 to root 2. So the sine of a 45-degree angle, I'll go off this one, is O over H. That's 1 over root 2. But I clean that up, and it becomes root 2 over 2. All right, so that is root 2 over 2. But is it positive or negative? What is the sine of an angle who landed in quadrant 2? All students says that the sine function of any angle in quadrant 2 gets you a positive ratio. So that's positive root 2 over 2. All right, then I have to times that with the cosine of 3 pi over 4. Well, luckily it's the same angle. So basically it's a quadrant 2 angle that has a reference of pi over 4. So then that means you're taking the cosine of a pi over 4 who landed in quadrant 2. Well, what's the cosine of a 45-degree angle? Cosine 45, if I go off this one, is A over H. So 1 over root 2, which is also root 2 over 2. But is it positive or negative? Well, this angle, was in quadrant 2. All students. Only the sine ratio is positive for angles in quadrant 2, which means the cosine ratio, the x-coordinate, is negative for angles in quadrant 2. So that should be a negative root 2 over 2. And now you multiply them together. So what's root 2 times negative root 2? That's negative 2 over 2 times 2 is 4. What is negative 2 over 4 going to reduce to? Negative 1/2. Okay? All right, so those are just some extra examples that I noticed that the online book had, and I wanted to make sure that I went over them with you.